Hey everybody, we had class and we started talking about muscle contractions and there was much wailing and gnashing of teeth. It's a confusing topic and we've actually not even gotten all of it in yet, but I thought it'd be good just to do a quick video to go over what we went and did in class again. I'm using the exact same slides from the PowerPoint. There's nothing new presented here, but you may want to go through it just to review to feel like that you have a pretty good idea before we get into a few more details in class next time. So just again, this will be kind of quick, but the two big ideas that we visited last time, I said two big themes of muscle contraction. One was the idea of excitation contraction coupling. There's going to be an excitation, a stimulus that's going to cause or start a chain reaction that will ultimately lead in the contraction, the shortening of the muscle. So that's theme one. And the other theme that we mentioned, hang on, and the other thing we mentioned was the idea that muscles, don't know why I didn't scoot over, but muscles are organs that will shorten, that are going to allow them to pull. So we're going to be talking about muscle contraction on the itty bitty scale, on the actin and myosin scale, to understand all the actin-myosins and all the myofibrils and all the muscle fibers of all the muscle are going to contract, which is going to result in a shortening of that muscle and pulling on a bone. So again, just to recap the anatomy quickly, this is a muscle cell. This whole thing, we call it a muscle fiber. That's the term for a muscle cell. It has parts that we know and love about cells. It has a sarcolemma, which is a cell membrane. It has a sarcoplasm, which is a cytoplasm, which contains myoglobin. It has mitochondria. It has nuclei. It has organelles or cell parts. The most prominent cell parts that we can see are these myofibrils, these things that stick out. Okay, in class we got into this whole idea of spaghetti inside of straws. Okay, the straw is the muscle fiber. The spaghetti put inside of the straws, those are myofibrils. If we look deeper at the myofibrils, we see they are composed of repeating segments or repeating units of actin and myosin. And we'll see it better on the next slide. But the orange thick ones here are myosin filaments, proteins, and the thinner purple ones here are actin. And this takes us to a discussion of a sarcomere. We said a sarcomere then is going to be a specific arrangement of actin and myosin. So in this case, the specific arrangement looks like this. We have a Z disc, which is right through a bunch of the actins. All the way over here, we have another Z disc, which is through the middle of some actins. But from here over to here is a sarcomere. And a sarcomere is a contraction unit. What's going to happen, and you see it, oops, I didn't realize I had this on there. What you're going to see is in this contraction unit that we see here, we're going to see a shortening. It's going to get like this because the myosin is going to pull on actin. So briefly, we have a band or a dark band because all the myosin and actin overlap. Here, just actin is there, so that's an I band. Here they all overlap. That's an A band. Here they don't. It's an I band. A band, I band, A band, and that gives us that striped appearance. But what I really want you to focus on is the idea that the striped appearance is because of the arrangement of the myosin and the actin within the myofibril. So this is just showing us a zoomed in view one more time of what myosin and actin look like. Myosin looked like a thick filament before, and you can see it over here, but when you zoom in, it has all of these heads that stick up, and these heads are going to try to grab actin if actin is available to be grabbed. And when you look at this, you don't really see quite the detail, but if I look here and then come down to this part, that's the same thing. Here on the detail, these little black dots represent myosin binding sites, where myosin could grab actin if it's available. Why would actin not be available? This tropomyosin is a regulatory protein that in this configuration is blocking those binding sites. So if this whole thing were up here, then myosin couldn't grab it because all the binding sites are blocked. However, if the tropomyosin gets moved out of the way, actin is grabbable at that point. Myosin can grab actin on those binding sites and pull it. What controls whether or not tropomyosin is in the way or if it's not in the way is this troponin complex. This is a segment where calcium could bind. If calcium binds to that troponin complex, it's sort of like putting a key into a lock. All of a sudden it springs open, and in this case, tropomyosin gets moved out of the way if calcium is present, because the troponin complex is going to kind of roll and push tropomyosin out of the way when it changes configurations. So when we get into what happens ultimately in the sarcomere is you see the shortening. I'm trying to show you with my hands. If I look at this, if you look at this distance here, this is the edge of a sarcomere. Here's the edge after there's shortening. And you notice that this distance here is bigger than this distance because the sarcomere got slightly smaller because it went like this. Why? Myosin could grab actin from both sides and pull in and shrink that sarcomere, which is a contraction. So a couple final slides to kind of get you thinking about what happens next. We said, okay, if there's going to be a contraction, it could only be a contraction if what is available? Calcium. Where is calcium? Calcium is going to be stored inside this yellow series of tubes. This is the sarcoplasmic reticulum. This is a calcium storage site. It's a modified endoplasmic reticulum, but it's going to be a modified storage site for calcium inside of a muscle fiber. If there's a stimulus that stimulates, that excites this muscle fiber, then you'll see a chain reaction that will happen, which will include calcium flooding out of the sarcoplasmic reticulum and now being available to bind to troponin. And now you should see the whole sequence of events. And we'll review that on the next slide. Okay, so we're going to pick up in class with the idea of what happens during a excitation part, what happens on the nervous system side. Here I gave you the short version. We'll know the longer version, but I'll give you the short version just for giggles. A current, an electric current, is going to excite the sarcolemma. An impulse is going to be sent down. In this case, here is the part of a neuron. It's going to be sent down to the end of a neuron, to what we call the axon, and it's going to cause an electric current is going to be able to jump the gap, jump the space between the neuron and the sarcolemma. When it does, it's going to excite the sarcolemma, causing a release of calcium. If calcium is now available, calcium is going to allow actin and myosin to interact because calcium binds to troponin, which moves tropomyosin out of the way. Myosin can now grab actin and pull. I will grant you this is not a simple process, and it takes some time and takes some practice. I would really encourage you to think about this in terms of the two phases, the excitation part and the contraction part. We've not done too much with the excitation part. You may think we have, but we're going to look at this process in a little more detail next time and talk about how an impulse can get from here and jump this gap and get to the other side and excite the sarcolemma. But the contraction part of the excitation-contraction piece is what we've already gone through. There's a little more to get to that in terms of how myosin actually changes shape and pulls on actin, but you should be able to now discuss the anatomy of a muscle fiber, including down to actin and myosin, and including troponin and tropomyosin, and be able to discuss the basic elements of a contraction at this point. If not, watch this video again, go back and look at your notes again, because you need to feel pretty comfortable with that series of events. Practice it. Again, watch the video again if you need to, but practice the series of events that leads to a relaxed muscle actually ending up with a contracted muscle because the sarcomeres get smaller. I'll stop here. We'll have a mastering and make sure you understand that. But again, seriously, this is important. Watch the video again if you need to. See ya.